So what does the number on the second ball have to be greater than?
It has to be greater than like 30 something.
Well, figure it up exact.
Greater than 28, I think.
So it has to be 29 or higher, right? Up to 44. So how many balls are there that meet that criterion?
There would be, so then you would take 44 minus 29 for the 29 that don't. So
well, that is the natural inclination to do, is to take 44 minus 29, but you have to add 1 to it. And the reason is, if I have row 1, row 2, and row 3, and I say how many rows are there between 1 and 3? Well, you don't take 3 minus 1. You take 3 minus 1 and you add 1 to it to come up with the proper answer, 3.
Okay.
You get it? And that is particularly relevant when you're working with spreadsheets, because with spreadsheets you frequently have so much data that you'll have a row 1, a row 2, a row 3, and you'll go all the way down and have row 495. So if you want to know how many rows there are in your spreadsheet between row 3 and row 495, you subtract the two numbers and add 1.
Okay.
That's if the first and last count, and in this case they do. In other words, 29 works and 44 works. So that is a total of 16 numbers. Probability is what? It's the number of successes divided by the number of possibilities. Well, there's 16 numbers that he'll be successful with. How many marbles is he drawing from?
4.
44?
Yeah.
Good, because he didn't replace the first one he drew. He kept it out. Had he replaced it, he'd be drawing from 45. So it's 16 divided by 44, which is equal to which of those answers?
B.
That's 16 over 46. Okay. Yeah, just divide top and bottom by 4. This one's a little tricky. That's a very interesting concept that you'll get in other things. For instance, if you're standing in line and you are third in line and your brother is 9th in line, how many people are in between you?
You have 7 people between you?
Well, this is a different case because I didn't say how many people are there counting you and your brother, only the people between you, which would be 4, 5, 6, 7, and 8, only 5. Well, we got that by taking 9 minus 3 and subtracting 1. So the whole key is whether this counts and this counts. In our marble question, it did. We were going from marble 29 to 44, and both 29 counted and 44 counted. In the movie line problem, when you say how many people are between you, you're not counting either the 3rd or the 9. So you subtract 1 in that situation. Or another way the problem will get presented to you is somebody lives on the 12th floor of a building and somebody lives on the 4th floor of a building. How many floors are in between you?
There's going to be 9. Okay, and 4 floors?
7. How many floors are in between you? In other words, the 4th floor wouldn't count and the 12th floor wouldn't count. The only ones that would count would be 5 through 11. 5 through 11 is 7 floors. So you don't always add one or subtract one. It depends on the situation. In other words, it depends on whether these count in your numbers or not. Next page. I don't know if we've done a problem like 58 or not, but there's almost certainly going to be 58 on your test. Now, they want the perimeter of this figure. Everything's a right angle there. In this particular problem, you could actually do it the hard way. In other words, you can figure out what this dimension is and what this dimension is. What is this dimension?
That would be 2.
What is this dimension?
4.
So now you just add them all up.
Okay.
However, there is a much better problem that is similar, only they don't give you a way to add everything up. It's the only dimensions they give you. What is the perimeter of that figure? And all of these are right angles. It's supposed to be.
I don't know.
The concept here is that when you take these notches out like this, it doesn't change the perimeter. Notice why. It doesn't change the perimeter from what it would be if it was just a rectangle. In other words, this little measurement here is this measurement here. This measurement there is that measurement there. This measurement here is that little measurement from there to there, and this little piece here is that measurement there. So the perimeter of the full rectangle is exactly the same as a perimeter of a notched rectangle.
Okay.
So what would the perimeter of this be?
Okay, wait. So, how do you get, so it would be, you have 40 across the bottom, right?
Uh-huh.
And so then you have those 2 little steps.
So the total from here to here has to be 20.
Yeah.
The total from here to here has to be 40.
Yeah.
So the perimeter of this object is 20 plus 40 plus 20 plus 40. In other words, 2 times the base plus 2 times the width.
So
regardless of whether it's notched or not, it does not affect the perimeter.
Okay.
So the easier way to do this problem is to assume that it is a full rectangle. A full rectangle would be 8 by 5. That's 13 times 2, 26 immediately, without figuring out what that side is and what that side is. in this case, you can figure out those two sides. But in the problem up here, they don't give you any more information. That's it. So there's no way to figure out the dimensions on any of these notches. But you don't need to.
Okay.
That's just kind of a good thing to memorize, because you'll notice at the moment you lay eyes on that problem when you get it. And if the memory goes off that says, that's the same as the rectangle perimeter. Not the same area, but the same perimeter. Okay, here is one of the conic questions about a circle. Give me the general formula for the equation of a circle.
For the equation of a circle?
Uh-huh.
I don't know that one.
Well, you need to know two of them. You need to know the general formula for the equation of a circle, and you need to know the general formula for the equation of an ellipse. So let's go through it. Circle is x minus h quantity squared plus y minus k quantity squared equals the radius squared, where h and k are the center coordinates of the circle.
Okay.
Well, in this particular problem, we said draw a square put a circle inside and tell me the equation of that circle. So first of all, where's the center?
2, 2.
And now fill out all the numbers in this equation. In other words, this is the general formula, so now give me the exact formula.
Use any points for H and
No, h and k are the center of the circle. That's what they mean. Whatever the center of the circle is, that's h and k.
X and Y, no matter what you use.
Always x and y. In other words, the specific equation is going to have both x and y in it, but it's going to have h, k, and r filled out. What's the radius?
2.
So there's my equation of that circle. Which one is that?
So that's
C. And the easiest mistake to make is to make it equal to r instead of r squared. So make sure you remember that it's r squared. Okay. Now let's talk about an ellipse. And really, if you know the two general equations of both of these, you'll get at least one of them right. You may get both of them right. The ellipse is very similar, except that's divided by a squared, this is divided by b squared, and the whole thing is equal to 1. Now let's talk about what a and b are. First of all, h and k are the center of the ellipse. So there's my ellipse. So whatever the coordinates are at the center, that's my h and k. An ellipse has a major axis. Half of that is what I call the major radius, that's A. Also has a minor axis. Half of that, that's B. In other words, So if I had an ellipse where A was equal to 3 and B was equal to 2, and it was centered at the origin, what would its equation be?
Okay. So it would be x minus 0
Uh-huh.
squared, and then over 9 plus y squared over
Over what?
4
Equals 1. So that would be the equation of that ellipse. If it was centered at any other point, then it would be x minus, it would look more like the circle one looked. Okay, and that may be the only two things you have to know about a circle and an ellipse. There's lots of stuff to know about these things. When you take conic sections in math, you'll find out about their foci and their reflective properties and horizontal and vertical ones and all of that. But for the ACT test, this is pretty much all you need to know is these two equations and what A and B are, and I suppose H and K. Now, frequently, let's talk about an ellipse one more time. Frequently, you will have something like this. That's the equation you will be given. How do I know that's an ellipse and not a circle? Because 16 is not the same as 9. If this was a circle, the coefficients would have to be the same. So I immediately know it's an ellipse because of that, but how do I get it in ellipse format? Divide every side by 144.
Oh, so they equal to
That's always the first step. Well, it's not always the first step, but it's generally the first step. And this now becomes x squared over 9 plus y squared over 16 equals 1. So when you see an ellipse that's not equal to 1, your goal is to make it equal to 1 in order to get it into standard format. All right, let's go on. So what was the price after Wednesday when it was reduced by 15%? So on Monday, it was $60. On Wednesday, it was how much?
so 60 times. Oh, is there an equal sign?
Yeah, there is. Do you have your calculator?
Yeah.
Well, you can take 15% of 60 and subtract that from 60. But the easier way would be to take 85% of 60, and that gives you the answer directly.
Oh, okay.
51, right?
Yeah.
Okay. 2 weeks later, it was reduced by 20%. So take, what is the price 2 weeks later? It was further reduced by 20%. And what that means is the 20% is being applied to the $51 price,
So then it would be 40.8.
Now, what percent of the original price is this last price?
Could you? Okay. So then, say 40.8 divided by 60.
There you go. 68? Did you get 68 or 65?
Got 68. The first time I did something weird and I got like 0.001.
Okay. All right, on to the second test. Now, sorry about the blurriness. Instead of just always doing the hard way, in other words, instead of just plowing into the algebra, I want you to take a second with each problem and see if you might see a shortcut.
Okay.
This is a good one to start with. Can you find a relationship between 2x plus 6 and x plus 3?
Yeah, it's double.
So what does 2x plus 6 have to equal if x plus 3 is equal to n? Uh-huh. That's the shortcut. The hard way would be to solve for x. So x equals n minus 3. Substitute. So now we have 2 times n minus 3 plus 6. Distribute 2n minus 6 plus 6. Well, that's equal to 2n. That would be the hard way. So recognizing that that's exactly twice that saves you 20 seconds maybe.
Okay, is it always formatted that the most difficult problems come
I don't think so on the test. But maybe. I just don't know. Most of the practice resource material that I use for the ACT, it seems to be that way. If I'm wanting to do hard problems only, I'll start at 30. Usually 30 through 60 are much harder than 1 through 30. But not always. And I'm not sure it's that way on the test at all. And you notice that question 60 was actually quite easy. It wasn't hard at all.
Yeah.
So, but in general, that's probably true. So, what is this?
That would be AB minus 0AC.
Which is? G, uh-huh. So you have 5 numbers, each separated by the same amount. What are the missing numbers?
So 37 separated by 7, then it would be negative 4, 17, and 31.
Okay. Again, notice that once you figured out the first one, they didn't have any other answers on there. So you really didn't even need to figure out the 17 and 31. It's always a good idea to scan all the answers before you plow into the problem. In other words, I think a common mistake people will make is they'll see an algebraic solution and they'll immediately work it through to the end, and then they'll check the answers, and the answers maybe didn't multiply out 2 factors or something, so they got to go back. So A lot of times if you look at the answers, you can spot stuff like that. Plus there's a lot of tricks like, pardon me for interrupting, but if you have a problem that has a lot of variables in the question, and you have a lot of variables in every single answer, the same variables, that is a giant red flag for picking numbers and solving it that way, picking numbers and back solving. So in order to notice that, you have to look at the answers, before trying to solve the problem. So I would say with every problem, you read it, look at the answers, and then go back and try to solve it. That would be the routine I would try to take. In other words, this is a perfect example. If we didn't look at the answers, we might spend a lot of time coming up with the exact number. What was the average price per CD that she paid? Well, what would we do? If we were trying to come up with the exact number, how would we write it?
Well, I would write it the way they did in G.
Okay, so in other words, $20 plus 5 times 8.49, all divided by 6. Had I not looked at the answers, I might be tempted to come up with a number for that, which is a whole bunch of wasted effort and would actually be counterproductive. Because if I come up with this number, that isn't on there. I would have to back up to the step that I had done to see that that is the answer, not the number that comes from that. All right, let's stop there. Got through 4 on test 2. So I will talk to you Wednesday night at 4:45.
Excellent, thank you.
All right, Sarah. Have a good one. Bye-bye.